Okay, so today we're going to be building or creating a simulation for an ultrasonic distance sensor. So you notice I've opened up a new circuit design. The first thing I'm going to do is change the name of this to ultrasonic testing sensor. Okay, so next time I come back to look for this, I'll know exactly what it is and where I'm looking. So we have that named. Now we're going to go ahead and add in the components to this. So the first thing I'm going to search for is the Arduino Uno R3. So I can take this and bring this out here. Um, and then after this, I'm also going to need a breadboard. So I'll do a search for a breadboard. And here we are. We only need the small breadboard. We don't need a super, super large one. So here we go. We have our breadboard, we have our Arduino, and now the last thing we need is, come on, there we go. The last thing we need is the ultrasonic sensor, distance sensor. Now there's a couple types that'll pop up. What we want is this one, and to make sure it's the correct one, when you pull it out, you should see HC-SR04. Okay, so once we have our three components to create the circuit, we can start wiring it. So one of the things, oops, let me zoom in just a touch. One of the things that we want to always do first when we're doing our simulations is wire the board so it has the ability to connect components to it. So I'm going to go ahead and plug in my 5 volts power, and I'm going to plug in the ground as well. And then one other thing that you generally should do for good practice is I'm going to wire one side of the board to the other. There is occasions where you wouldn't do this, but for something as simple as this test code, we are going to do it. Now you can see us with all these green wires, it starts to get confusing. What I would recommend you do is change your power supply side or the voltage side to red, so it's color coordinated. These wires don't mean anything for how the circuit actually functions. I should say the colors of the wires don't mean anything, but it helps you stay organized. So right now I have electricity being able to flow through these two channels and to this side as well. Let's talk about our ultrasonic sensor. You'll notice that there's VCC, so that's for our voltage. I'm going to go ahead and plug this in as well. You can plug it into either side. Just make sure that your VCC is plugged in to the plus. And I'll change the color of this to red. And this side is our ground. Okay, and this will plug into our ground side, and I can change the color of this to black. So right now we have the majority of the wires actually already connected. The last thing we're going to have to do is connect our ultrasonic sensor to the Arduino board so it can send and receive signals. One thing I'll note right now is I know your robots might be built slightly different, but you have to make sure that you have two spots available on this digital input side with these squiggly lines. These squiggly lines allow for pulse width modulation, and what that does is it allows the ultrasonic trigger to send pulses of ultra frequency sound. So I'm going to plug in this ultrasonic sensor trigger. I'm going to go to pin 10 for the trigger. And for our echo, I'm going to go to pin number 9. So the ultrasonic sensor works a lot like a bat's hearing and ears. It's going to send out a frequency that you can't hear with your human ears, but this sensor can pick up the frequency of the sound with these speakers, and it can send the same frequency as well. So right now we have everything wired, and we're looking pretty good, and we're ready to start the code. So I'm going to change this from code from blocks to text. Yep, I want to continue. I'm going to get rid of all this stuff right here. And at the top, as usual, I'm going to title the program title, ultrasonic sensor test. Okay. Then I'm going to add programmer, Mr. Mancari, and then I'm going to add what the program does. Description. Oops. This program will test to see if the ultrasonic sensor is working properly. All right. I know that was a mouthful. I'll slide this out to the side so you can see it. Okay. So what we're trying to do right now is write a code to see if our sensor is working properly or if we might have any other errors for it. The first thing we do with almost every single code you'll ever write is declare the variables. All right. And the way we're going to do this is the way that we've always done it. We're going to set this as a constant, int or integer. And the variable I'm going to set first is for this trigger pin. Okay, that's the side that's going to be making the noise. That's the bat's mouth or the bat's vocalization. So right now we see that this trigger pin is connected to pin 10. So I'm going to set trig pin equal to 10. Remember, our lines of code finish with a semicolon almost always. I'm going to set a const int for, well, what's the other one? Echo. So I'll type in echo here. And echo is plugged into pin 9. So echo equals 9, semicolon. That's it. So now we have our variables that this Arduino is going to control declared. Now we have to set them up. So void setup. Okay? And then we'll have to have parentheses after this one that's letting it know that there's a variable or a function that's going to occur after. And I'm going to start that with a curly bracket. So I want to set these pin modes for trigger as an output. Okay, the trigger pin is set as an output. It's the thing that's sending out the sound. The other one I want to set is pin mode. Here's the variable. The variable's echo. And echo is waiting to receive the signal. So that's coming in. That makes it an input. And then there's one other thing here that's going to allow us to monitor how the signal is being received and sent. And that's serial dot begin. So the serial is going to keep track of the information. And this is setting a thing called a baud rate. And that's just how fast the information comes in. We're going to set it at 9600. So our setup now is complete. Now we can get to writing the actual program. As with any program in Arduino, it is a void loop. That just means the program is going to loop through whatever the set of instructions I write down are. So what I want to do is digital write. I want to send a signal out. I'm writing a signal out. I want the trigger pin to start low. All right, we'll put a semicolon at the end there. I want a delay in microseconds of 2. Okay, so that's a really, really quick dee-dee-dee-dee-dee. It's almost like a Morse code if you can think about it like that. It's very, very low. It's just turning off for a second, and then we're going to have a digital write trig, comma, high. We're going to turn it on. So it's off for a short bit, then it's on, and it's going to be on for 10 milliseconds. Now, one thing we can do is take this line of code, and this kind of helps get rid of typos or the potential for typos, and copy and paste this down here. But this one I want to change to 10. I want to make sure that that's at 10. And then just for good measure, we're going to turn this off again. This is to try to avoid signal confusion or what they refer to as noise. So right now, you can see that as this code starts, we're going to have our trigger pin, the one making noise, off very short period of time, then making a beep, and then off again. Now we have to get the echo pin set up so it can receive the signal. I'm going to type in long duration. All right, so that's just a data type. It's going to allow us to carry in decimals. It's not an integer, so it'll have a little bit better precision for receiving the signal. So this is going to be pulse in, and the variable that's getting the pulse in is the echo, and we're waiting for it to be high. Okay, it's determining when that high signal is coming back in. The next thing I'm going to write is int distance. Oops, need a little space there. Distance is going to be equal to, this is where it gets a little confusing, but stay with me. It's going to be equal to the duration. So this trigger pin sending something, a signal out, beep, beep, beep. This one's hearing it. So the distance is figured out by the duration times 0.034, and then we're going to divide that by 2. The reason we're multiplying it by 0.034 is the way that the circuit's built, and also how fast sound travels. Now, it gets divided by 2 because the signal is actually going out to the object you want to detect in front of you and then coming back to you. So you need half of it, or to divide it by 2. So that's why we have this here. So we have our trigger signal getting out. We have our echo system, our echo side of the sensor hearing it. So everything looks good here. Now we just need to be able to see it. And that's where this serial comes back into play. So we'll type serial print because we want this to kick out the information. Serial print is going to be this first variable, or this first thing I'm writing. If I put a quotation here, it's just going to display the exact thing that I'm writing. So I'm going to make the distance equal to. So there's going to be a line of text that shows up that says distance equal to. All right, so what is it going to be equal to? Let me put a semicolon at the end there. Well, I'm going to write that in right now. Serial dot print. The next thing that's going to come after this text is distance. And the difference between these is this is a written word. You see how it pops up in red? I know that because it's in quotations. Technically, this is a string. It's just a string of characters. That's why it's referred to as a string. Now, this distance is an actual variable. Right here, we set that distance as a variable equal to something. So it's going to print out the word distance, then tell you what the actual distance is. And then I'll have a semicolon after that. Oh, got a little pop-up right there. Then I'll have a semicolon after that. Let me fix this typo real quick. And then the last thing that I'm going to add to this is serial.print line. And I want, when I'm reading this, to know the unit of measurement is centimeters. So that's why we put in the centimeters. Again, this is a string of characters. That's why it's in the quotations. This line right here, LN, not IN, that ends the line. So every time the information comes up, it'll start a new line, okay? So let's take a look here. Let's zoom out over here. I'm going to move this back a little bit just to make it a little easier to see what we're working with. Down here, so if you're wondering, gee, what the heck, why do we keep writing serial? There's a thing called serial monitor. And whatever you ask the program to print to you, serial print to you, will show up in this serial monitor. So if I go ahead and start the simulation here, oops, looks like I have a little typo. Everybody does it, not a big deal. Oh, my Lanta. What else do we got? Serial print line. Oh, this is a simple one. I needed a curly bracket at the end here. So this list of instructions, it doesn't know when it's complete until we have this at the end. So for this void loop, that's the start of the instructions. This is the end of the instructions. And that's actually what it was telling me down here. I was expecting that. So let's try it one more time. Oh my gosh. One last one. Semicolon. Okay, man, Carrie, you got your act together now. All right, so let's take a look at this serial monitor. And we can see this distance is kicking out 110. Cool, but where's that information coming from? Once we open this up, we can see as we change this, the distances here are changing. So once we have this set, we can download this into our Arduino board, set up the ultrasonic sensor, and make sure that it is functioning properly. Once you get that done, let me know. I'll help you download when we can check and come up with a test for this. Good luck.